All right, number one, we have this equation here, y equals 3 times the sine of theta over 4 plus 135 plus 2. And this, you'll notice this 135, that's in degrees. We're given this graph in degrees as well. So what we're trying to find here is all of this stuff in degrees. We're asked to find the amplitude, the period, the phase shift, and the vertical shift, and then sketch the graph. All right, let's start with the amplitude. The amplitude is always going to be this number right there. And so the amplitude here is going to be 3. The period is going to be 1 full rotation of the unit circle, so 360 degrees in this case. 360 degrees divided by this number in front of the theta. Now here, that's 1/4, so this is 1/4 theta. So 360 divided by 1/4 is the same as 360 times 4. So that's going to be 1,440 degrees is going to be our period. All right, and then the phase shift, that's how much it's going to be shifted to the right or left. The phase shift is going to be this number, 135 degrees, divided by b, this number in front of theta. So 135 divided by 1/4, that's the same as 135 times 4. So that's going to be 540. Now remember from transformations that if we're adding something inside the parentheses, it's going to go the opposite direction of what we would expect. So if we're adding 135, that means it's going to be shifted to the left. So this phase shift is going to be to the left 540 degrees. And then the vertical shift is just this out here at the end. And this does go the direction that we would expect. We're adding, so it's going to go up. So this vertical shift is going to be up 2. All right, so now to graph that, let's start with this vertical shift. Since we're shifting it up 2, what that's going to mean is that our midline, instead of being right at 0, as the midline for a sine function normally is, it's going to be shifted up 2. So our midline is going to be here at y equals 2. So there's our midline. Our amplitude is 3, which means that our maximum is going to get up here to 5, and the minimum is going to get down to -1. The period is 1,440 degrees. So this is pretty stretched out. That's how long it's going to take to go through one full cycle. And the phase shift, that's where we need to start here. The phase shift it's shifted to the left 540. This is a sine function, so remember the sine function starts at the midline. But since we've shifted it to the left 540, that's going to be back here somewhere at -540 on the midline is where this thing is going to start. And then one full cycle from there, one period from -540 degrees is going to be, let's see, -540 plus 1440 is going to be at 900. So we know that we're going to get through one full cycle by 900 degrees. And then halfway in between these, we're going to cross the midline again. So halfway between -540 and 900 is going to be here at +180. Right, at +180. So it's going to cross, it's going to start here, it's going to go up, it's going to come back down here, and then be up here again at 1440, or sorry, at 900. And then halfway between these 2 points, it's going to reach its maximum of 5. So it's going to reach a maximum of 5 up there somewhere. And halfway between these points, it's going to reach its minimum of -1. And if we continued this out a little farther, let's see, 900 plus another phase would be 2340. So that's going to be out here somewhere. And then halfway in between there, that's going to be 900 plus 720, which would be 1620. That's right here. All right. And then halfway between these 2 points, we're going to reach a maximum again. So right here, we're going to reach that maximum of 5. And now we've got enough points that, and we know what the sine function looks like, so we can start to just draw this curve here, and it's going to look something like that.